Another important aspect of Python lists is that they can be iterated. They are iterable. What does it mean for a Python container, for a Python data structure to be iterable? Well, that it can have some associated iterator. And an iterator is a Python function that gives me all the elements in one container in order without missing any and without giving me the same element twice. Okay, so lists can be iterated. I can get all the elements in my list in order without missing any. And there are several ways to do this, but one very widely used way is to use the range function, which gives me, given up to 3 parameters, a list of integers, a list of indices generally. Okay? And the 3 parameters are start, stop, and step, and they work exactly in the same way as I have just described for list slicing. So I will not stop into it too much, but here you have some examples. And we will be using this range function to build loops to iterate our lists. Okay? We will see two main algorithms to iterate to work with our lists. We will see list traversal and list search. And let's begin with the first one. In list traversal, I'm going to visit in order using the iterable property of my list all the elements on one particular list, and I will be doing the same thing for each element. Okay? So I have a list here, and I will go over all the elements, and I will do the same thing in each of them. One way of iterating them is to use this syntax, for example, for X in L. We'll be seeing others in a second. Let's see an example of this. For example, I may want to count how many negative elements my list has. In order to do that, I will use a simple algorithm that visits every element, all of them in order, and then for each element it checks whether or not this element is negative. If it's not negative, it doesn't do anything, and if it's negative, it updates one counter. At first I initialize this counter variable at 0 value because I haven't found any negative elements in my list yet, and then at each element, at each position of the list, I check whether or not I have to update them. So for example, here I don't have to update it, then I would move because I have to visit all the elements in my list in order because I'm doing a list traversal. That's what it means, visiting all the elements and doing the same thing at each of them. And here again, I don't need to update my counter. Same here. Here I would need to update my counter. When I check this element, I see that this one is negative, so I have to update my negative number counter, so on and so forth. And in the end, I would have updated my counter here and here. I reach the end of my list and I'm done, and I have counted 2 negative numbers in my list. Let's see some code regarding that. Okay, so for example, I have also used range to create a list. Okay, so I have this list that contains range of 25. So start is 0 because it's not given, and end is 25, and step is 1. So I get this list from 0 to 24, as we were seeing for list slicing. Default for start is 0, and I index up to this position, which means that this position is not included. So 25 is not there, but 24 is. Okay, and I have used the list constructor, the list function, to create a list with this. So I will first use this for element name in list name to traverse all the elements in my list, and I'm going to do one very simple thing, which is just to print them. Okay, so here at each step of the loop, I'm visiting one element on my list and printing it. on the screen. Okay, so for name of the variable I want to use in my list is the first very simple way to traverse a list. Okay, in this case I'm doing print el because I have named my iterator variable el. Okay, we can even do this combined with slicing. Okay, I'm going to do the same print loop, but not with my list, but with the result of slicing my list, jumping in threes. Okay, so I'm going to get position 0, position 4, and so on and so forth, and get, with this very simple code, code that prints on the screen the multiples of 3. Okay, let's see some code to do more list traversals. Okay, for example, let's count, as we have seen, the negative values on my list. Okay, I'm generating one list using, again, another version of range, another call of range, and this gives me this particular list that contains negative and positive values. And then I'm going to use the algorithm that I intuitively demonstrated in the slides, which is that I initialize a count. I called this variable numNeg in the slides. I'm going to call it count here, and then I will have my traversal loop for x in my list, and I'm going to just for each position I'm going to check whether or not it's negative. If it's negative, I'm going to update my count. I'm going to add 1 to my count. After doing this, I get the correct result that the list contains 7 negative values. Okay, because 1, 2, 3, 4, 5, 6, and 7 negative values. Okay. Another very simple traversal example is to generate a few random numbers and put them in a list. Okay, so I'm going to define a function which is called random int list. This is my exercise, and I'm going to receive an and 2 limits. So I'm going to generate n random numbers from limit 1 to limit 2, and what I'm going to have is just a loop that iterates n times from 0 to n minus 1 by using the range function. I said before that we would be using range to do list traversals too, so here it is. I'm setting up this traversal loop of the list of integers from 0 to n minus 1 so that I have n iterations. And at each iteration, what I am going to do is to generate one random number using the randint function between the limits that I have been given. Okay, and if I run it once, I might get these numbers. I'm running it, generating 10 numbers between 0 and 10, and I run it again and I get other numbers. If I want to do it between 0 and 100, I can also do that, and I get different numbers. I could do between minus 50 and 100 and do 7 numbers instead of 10, and that would also work. Okay, let's just go back to the 10 and 0 and 10 because they are let's say a bit neater for the notebook, but I have done a function that using list traversal generates a list of random integer numbers. I have some more code here to check how many elements are bigger than 5 in one particular list, and I'm trying to make the code a little bit more complex by doing some things. If the element that I'm traversing, that I'm visiting in my traversal, holds one condition and something else if it does not. So basically what I'm doing here is that I'm first generating a random list, and then I'm checking for each position and building a new list that says true if this element is bigger than 5 and false if it's not. So I again have the traversal loop of my random in list, which I have created with a call to the previous function. So I'm using functions here, something that we saw in previous courses, and I'm building this Boolean list, which I initialize as a empty list, and I update using append at each iteration of the loop. Okay, and we can run it again and check that yes, for each position we get the correct value. These two are smaller than 5, so I get false. This one is bigger than 5, so I get true, and so on and so forth. Here you have a bit of a, let's say, fast forward or looking forward part of code where we use the zip function. Okay, so if you're interested, do have a look at the zip function. We will speak about it more in a later course, but it's a very convenient function for many things.